Hello and welcome to Tribe Topper. In this video session, you are going to learn about power and efficiency. So, what is power? We say like somebody can do a work in 1 minute and another person does the same work in 2 minutes. So, who will have a greater power? Obviously, the one who has done the work in 1 minute. So, how would we define power? We'll say power is the rate of doing work. So, we write it mathematically as power is equal to work over time, or in notation form, P is equal to W over T. And from this expression, we can also define the SI unit of power. What will be the SI unit of power? It is watt, and we denote it as W. So how will we define the unit of power? We'll say 1 watt. Whenever we have to define any unit, we put everything as 1. So if I'm saying 1 watt, then work, the SI unit of work is 1 joule upon 1 second. So that means if 1 joule of work is done, right? If 1 joule of work is done in 1 second, the power is 1 watt. There are some bigger units of power also used, like you have 10 to the power 3 watt, that would be written as kilowatt. If you have 10 to the power 6 watt, that would be written as megawatt. So you can decide based on the question that is given to you. So let us solve this problem, which says a car of mass 1000 kilograms accelerates from rest to 100 kilometers per hour in 5 seconds. So let's write down whatever is given to us. First of all, the mass of the car is given, that is 1000 kilograms. And it accelerates from rest, that means initial velocity is 0, and 200 kilometers per hour. So what's going to be the final velocity? This is 100 kilometers per hour. So I'll multiply it with 5 by 18 to convert it into meters per second. And this comes out to be roughly 28 meters per second. So we'll round it off to this number, 28 meters per second. Now, as we can see here, to find the power, we need the work. And what is the work done here? As we know by the conservation of energy rule, that work done, if the speed is changing from some value to another value, like in this case it is changing from 0 to 28 meters per second, then what is going to be your work done? The work done is equal to the change in kinetic energy or the gain in kinetic energy that has happened, and that will be half mv square minus half mu square. That gives me half times m is 1000 times v square 28 square minus 0, because my initial velocity was 0. So the gain in kinetic energy is simply half mv square. And solving this is 500 times 28 square and 392,000 joules, or you can write it as 392 kilojoules, because whenever you have this 1000, preferably write it as kilojoules. And in how much time this happened? This happened in 5 seconds. So we have the time 5 seconds. Therefore, what is going to be the power? The average power of the car is the work done over time taken, which is 392 times 10 to the power 3 joules over time is 5 seconds. And solving this, we get 78.4 times 10 to the power 3 watt, or you can write it as 78.4 kilowatt. So this is how you can determine the power from the work done, if you know the work and time. Okay, next thing that we have is efficiency. See, whenever we are talking of a motor or a machine, what matters to us the most is its efficiency. So efficiency basically is something which determines how much is the useful work performed by a given input work. So whatever input we give, how much output do we receive corresponding to that? That is called efficiency. So mathematically, you can say efficiency is equal to work output, or we also call it as useful work, over the work input. If we do it in terms of power, because if you divide this by seconds, you can also say it's the power output over the power input. So in notation form, efficiency is denoted as eta. So eta is equal to the output work over the input work. And if you just multiply it with 100, you get your efficiency in percentage. So let's do a problem based on efficiency. So here we have a box of mass 10 kilograms is pulled along the floor for 2 meters by a horizontal force of 50 newtons. If the frictional force is 20 Newton, what is the efficiency of the system? Let's just visualize this situation. So as we see here, there is a 50 Newton force which is applied horizontally. And so we would say the applied force is 50 Newton. And this force is able to pull the box along the floor by 2 meters. So the distance moved S is 2 meters. It's in the same direction, so your theta is 0. Therefore, the work done is simply the force, applied force times the distance S. So I'll use here applied force. So 50 times 2, that is 100 joules. Now this is the work done by the pulling force. But do you think that all the work is going to work on the block to pull it? This is the work done by the force. Now, how much work is actually performed on it? Because you can see there is a 20 Newton frictional force acting. So what is going to be the work done by the frictional force to resist the motion? Right? Work done by the frictional force. How much is that during all this distance? That will be equal to 20 times 2. So that's 40 joules, right? 20 Newton force is the value of force of friction and it is moving through 2 meters. So during all this time, the frictional force has done a work of 40 joules. Therefore, how would we find out what is the useful work? So therefore, I'll say the useful work is the applied or the work done actually minus the opposed work or 40 joules, which is a resistive work. So 60 joules is actually able to move the block. So this is our useful work. But how much was our total input work? This I can write as Wi was my input work, 100 joules, which was applied by the force. But at the end, I have it as 60 joules as an output. Therefore, what is the efficiency? Efficiency eta is equal to 60 upon 100. That's output work. You can actually first write the formula output work over the input work and then plug in the values. So that's 60 by 100. If I multiply this with 100, I simply get my machine or my force here or efficiency of the system here is 60%. So that's all in this video session. In the next session, you're going to learn about collisions and momentum.